Pawan sir, thank you. So today we have Professor Amandeep Kaur ma'am from Central University Punjab. So I just give some brief introduction about her. Dr. Amandeep Kaur received her BTech degree from Electronics and Engineering from the Nagpur University in 1996. He has done in ME from Thapar University in 2001 and PhD from Punjabi University Patiala in 2013. She was associated with CDEC Mohali from 2001 to 2005, and she also worked with a different position at Punjabi University Patiala from 2005 to 2015. In 2015, she joined Central University Punjab as an associate professor. Now, presently she is working as a professor in computer science department. Her research area includes image processing, computer vision, and artificial intelligence. And she has published more than 50 research papers in reputed international journals, conferences, and book chapters. So this is all about our resource person. So welcome, ma'am. Welcome for this workshop. So Pawan sir, it's up to you now.
Okay, ma'am. Ma'am, you may start your presentation, and I welcome you all on the behalf of all the participants from the organizing committee of Department of Computer Science, IGNTU Amarkantak.
Thank you so much. So I'll just start. Hanji, I'll share my presentation.
Please, ma'am.
So a very good morning to all the participants. And so we are together here for an interesting topic that is supervised machine learning. And in that, we are focusing on classification today. Artificial intelligence, machine learning, deep learning, they are very vast areas. And we always keep learning in these areas. They are changing. So very briefly, we'll start with AI. It is basically developing intelligent machines or intelligent programs, we can say. And it is interdisciplinary. There is, you take inputs from neuroscience, psychology, and maybe mathematics, economics. So it is all interrelated, and through that we try to develop some intelligent machines or computers. So there have been, we can say, 4 views of AI in literature that we think. So in AI, either we are focusing to make machines with minds, that is, they think like humans, or a simpler version, you can say, acting like humans. Right? So in this case, we're only focusing on the output. So we study how to make computers do things at which at the moment people are better. Then thinking rationally, not only thinking, but thinking in a logical way. And then acting rationally. So if we talk about robots, it is moving in its environment, or we have written a software which can play games like a human. So they are going to make moves which are logically the best and which will help them to win. Right? So AI is concerned with intelligent behavior of artifacts. So focusing on these things, different algorithms, different machines, you can say, they perform their actions in some intelligent way. So there are key research areas in AI, and machine learning is one of them. So in machine learning, what we try to do, we are trying to get intelligence from data. Because we talk about big data today, we have through digitization and everything, we have large amount of data which is available with us. And so machine learning is focusing on extracting intelligence from data to adapt to new circumstances, to detect and extrapolate the patterns, So then we have natural language processing, we have computer vision, we have robotics. So all these are some of the key areas of AI. So today we are focusing on machine learning. So basically, these are all the things where we were thinking, we were talking about 4 views about how AI works. So acting rationally. So in this case, AI means performing some actions that increase the value of the state of the agent. So agent could be a physical agent like a hardware robot, which is performing some physical actions, or it can be a soft bot, like you have Alexa. So environment in which the agent is acting. So if an agent is playing a game, it will act rationally if it tries to win the game. So what moves will make it win? Accordingly it is performing, right? So rational agents, like you have self-driven cars these days. So they are basically rational agents, right? Because they see their environment and accordingly they make their decision. So somewhere down this line, when we talk about the self-driven car, it is making use of the data to get intelligence. It has different sensors. It is capturing some real-time data from its environment. It has some stored data. It is getting data from other self-driven cars to get the status of the roads and traffic and things like that. So it is getting a lot of data, and from this data they are trying to make some intelligent decisions, right? And then perform some actions on that. Then it becomes a so it is some kind of a rational agent which is making use of machine learning also, right? So it is a very, very vast area. So many a times we are just thinking what is the difference between AI and machine learning, deep learning. So this was a table I got from internet only. So they have described it well in a very nice way. So initially AI originated, and AI represents some kind of a simulated intelligence in machines that could be done using different techniques. It could be knowledge based. So you develop some knowledge bases and you have some knowledge representation languages, and based on that you develop intelligent machines. They are symbolic, and then you have neural networks, then you have machine learning. So in different ways it can simulate intelligence in machines. So if we see, AI is basically the subset of data science. Uh, and it aims to build machines which are capable of thinking like humans. Right? They think like humans, and they are able to do the things at which we are good at this time, like pattern recognition. So AI was initially used for such applications, like if I see a person walking towards me, I can very easily recognize that person. But if you use a traditional computer program, it won't be possible to um, develop an efficient algorithm which will recognize that person, right? So only thing is, if I have a database with maybe 100 people and he is one of those 100 people, then I'll compare it with all those 100 people to find out who he or she is. And that won't be an efficient method when the data size increases. Whereas in AI, like in deep neural networks or neural networks, I just detect the face, give it as input to the neural network, and it will recognize that person, right? So whatever was difficult with traditional programming became easier with AI, you can say. Machine learning, we say it originated around 1960s, but in 1952 it got its name, machine learning. One of the authors he had from IBM, he wrote a research paper. He developed an intelligent program for playing a game. So machine learning is the practice of getting machines to make decisions. So machines are making intelligent decisions, and that is without being programmed. And how they are able to make their decisions? From the data they have. From the data, they are able to extract some information which helps them to make decisions, and they're not programmed for it. Right? Machine learning, we can say, is a subset of data science and AI. So out here, the aim is not to make the machines think like humans, but the aim is to make machines learn through data so that they can solve problems. So it is very, very important if you have an autonomous robot, it is going through an environment which is new. So it is getting something from the environment, some new data, and based on that, it is updating its behavior. And then now we have deep learning. So it originated somewhere in 1970s, and that is using artificial neural networks to solve complex problems. So deep learning is a subset of machine learning, AI, and data science. And its aim is to build neural networks that can automatically discover patterns for feature detection. So normally, when previously we were working on classification or such algorithms, what we had to do, we had to extract some features from the raw data. So if I am talking about face recognition, or I am talking about some medical imaging, and I want to find out if the patient is suffering from specific type of a cancer using that maybe the CT scans or MRI images, then I'll compare those images in a normal way. But in normal classification methods, we had to extract some features because otherwise our data size was very, very large. So the complexity, time complexity increased. But in case of deep learning, it will take raw images and it will extract the patterns on its own and then use it for classification. So for different applications, we had to find out which features are the best. So there are large number of features, and that was a challenging issue. So like I said, in 1952, Arthur, he has given this term machine learning. And in 1990s, the focus shifted towards machine learning when the focus moved away from knowledge-based approach. Knowledge-based means we know everything about that problem and we store that knowledge in a knowledge base. And then the inference system will use that knowledge to reach some conclusions, some inferences. So for that, some kind of knowledge representation is needed, like maybe they use predicate logic and things like that. But from the knowledge-based approach, the shift was there towards the data-driven techniques in 1990s. So this was a critical decade in the field of evolution as scientists began creating computer programs that could analyze large amount of data and learn in this process. So now big data availability, you have new machine learning techniques, and you have GPU acceleration. That means you have more powerful machines now which can handle large amount of data. So with this ever-growing volume of data, the ability to gain insight from this vast data set is one key to addressing enormous array of issues. So maybe you want to treat some diseases more effectively, you want to fight cyber criminals, you want an automated system which will, you have AI in law now, you have AI in food technology. So all this has been made possible with the large amount of data which is available now in digital form. So with this brief introduction, so we are going through different concepts in machine learning. So we are focusing on the supervised learning. So in the supervised learning, we have two kinds of algorithms which we normally study, classification and regression. So whenever you have discrete classes and you want to categorically put your input into a different class, then you use classification. If you have your output is a continuous value which you want to predict, um, like you depending on the house area, its material used, its location. So there are some input parameters, and based on that, you want to predict the price of a house. That will come under regression. That is continuous value. But if you have a medical image and you want to classify it as a normal image or a person suffering from maybe lung cancer, so you have the lung medical imaging, you give it to your machine learning algorithm, and it will either classify, it will put it in the normal class or the diseased class. So when you have discrete classes, then we talk about classification. So in today's this lecture, we will be discussing about classification. So one thing is important to know that in machine learning, there was a shift from symbolic approaches in AI to models from statistics and probability. Right? So AI was initially using symbolic approaches, but in machine learning, there was a shift towards statistical and probability-based techniques. So it uses statistical methods which basically enable machines to improve with experience. So we are using some kind of statistical methods. So methods to enable machines to improve with experience. Experience from where they get experience? From data. So it is getting more data and that they are learning from that data. So we had seen that types of supervised learning is classification. And in this, when we have defined labels or discrete values, we know different classes. And like Gmail classifies mails in more than one class, like social, promotions, updates, forums. So there are discrete classes, and based on the some parameters, we see if this email belongs to which of these categories. So this comes under classification. In the same way, neural networks also is a type of classifier. You can use supervised neural networks. So you have an input, maybe you have a text, which is your handwritten text or characters like A, B, C, D. We write it and we give it to the classifier, and it will put it into one of these classes. It is A, B, C, or Z. So these are all examples of classification. Whereas if we talk about regression, we talk about continuous values. We want to, wind speed is not any discrete value, but we want to calculate its value. So our goal is to predict some continuous value. So in this case, we use regression model. So we had already seen the major difference between classification and regression. So we are focusing on classification and supervised learning. So what we are trying to get, we are applying supervised learning for classification. So you have a label data in which you have labeled this shape belongs to hexagon, this is triangular, this is square. So your training data set will have inputs, and for those inputs you have specified what is the correct output. Right? So based on this training data set, you train your model, you show it this, if this is the input, this should be the output. If the model is not giving the correct results, then the changes are made in that model till it starts giving you the correct answer. So once the model is trained, now you use it for prediction. So you give it the test data. Maybe if I give it a square, it will predict that this is a square. If I give it a triangle, it will correctly predict this is a triangle. So this is a very simple example just to show you that supervised learning, what it means, that there is a input output pairs which are used by the agent or by the model to learn. And then once it has learned, then it is going to predict the value. If it puts the inputs in discrete classes, then it is classification. If the output of the prediction is some continuous value, then it is regression. So when we talk about a generalized classification block diagram, right? So this was a very, very simple, small example. In this case, maybe I show this model, small images of hexagon, brick, square, triangle, and I've marked, right? Okay, this is the image of a triangle, this is square, and accordingly it is giving me the output. In the same way, what I can do is, maybe I want to diagnose the skin cancer type using classification and supervised learning. So first I will make a data set. And what that data set is, how I'll make it, I will take maybe 500 images of a normal skin without any type of cancer. Then I'll take another data set for a specific type of a cancer of those patients, and I will mark it as a specific cancer. Then I'll take another class and I'll take the images and I'll mark them as a different cancer. So I have a data set which is labeled. Now what I'll do, I'll give one by one all the images. I'll see what the model output is. I'll compare it with the desired output which it should give. And that error is given back to the model for training so that it starts giving correct answers. But if we can't just, we can't give the raw training data to the model itself. So in between, there is a step which we call as feature extraction. So if I have an image and that image size is very small, even if I take 100 by 100 image, that means it has 100 rows and 100 columns. That means it has 100 into 100. That is, it has 10,000 pixels in it. Right? So it has 10,000 values. And if I consider a grayscale image, then each pixel is represented by 8 bits. So I have 10,000 pixels and each pixel is represented with 1 byte of data, you can say. So for saving one small image of size 100 by 100, I need 10,000 bytes. And if I am using this training data set, and if I have 100 images, that means into 100, 10,000 into 100, that much of space is required. And for each classification step, in the database, I have 100 images. So each new image which I get, I compare it with all the 100 images in my database to find out its class. It is similar to which data set image. So I have to compare pixel by pixel. So if there are 10,000 pixels, that means I have to subtract 10,000 times. And then I sum up that difference to find out the total difference between the two images. So that will be lots of calculations, lots of storage which is required. So normally traditional classifiers, how they work, and then maybe I'm using it for face detection. So one, I have the person's image, face image, and the other image is rotated. So when I compare both of those images, they are not similar because one, though it is of the same person, but the image is rotated. So when I compare it pixel by pixel, they are misaligned. So it will give me the wrong results. So in traditional classifiers, with the training data set, I also need to extract features. And there are different types of features which there are pixel domain features or spatial domain features. There are transform domain features which we can find. There are features based on some different movements. So there are certain features which are rotation invariant. If you have a straight image, you have a rotated image. And if you find the features from those images, those features will be same. There can be simple features like histogram of an image, right? Statistical features could be there. So for each application, I had to apply a handcrafted algorithm to decide what kind of features are suitable for that type of application and classifier. Do I want those features to be rotation invariant, scale invariant? I have the same image, but its size is different. So the two features, if they differ, that means they are not scale invariant. And so this was a challenging, you can say, research gap. So whenever I wanted to use any of these classifiers, I have to decide which kind of features I require. Like in the previous example, we had seen this emails. We want to put them into different categories. So from those emails, what kind of parameters I need to extract, what kind of attributes I will need, that will help me to compare the two emails and put them in different categories, which will differentiate them according to their categories. So you have a training data set. From this training data set, we extract some kind of features, and then using those features, we train the machine learning model, and we give those features as input to the machine learning model. It will give me some output. Right? And what output I get and what is the desired output which I'm getting from the training data set, I will compare both these output. And based on that, I will get the quality matrix that will tell me how close the output given by the model is to the desired output. So if there are differences, then the machine learning algorithm will change the weights for the machine learning model so that the model becomes better trained. So that next time when I give the same input X, and I extract the features and give it to the model, it will give me an output which is closer to the desired output Y. So in this, a normal generalized classification is there is a training data set. In supervised learning, we will have a training data set in which both the inputs and the desired outputs are specified. Then we can't just use the raw data as such. We will extract some features from that and give it to the model. So when those features of the input are given to the model, it will give me the output. Ideally, we want this output should be same as the desired output. There shouldn't be any difference between Y and Y dash. But when the model is not yet trained, they will differ. So based on that, we get some quality metrics which are given to the machine learning algorithm. And according to the difference between the desired and the actual output, the machine learning algorithm will train the weights of the machine learning model. And this process will continue till the model is trained for all the input types. And finally, the model will have weights which will give me the desired output. So this was the generalized classification model. So normally we have two types of classifiers. We have binary classifiers, which have only two types of outputs. 1 and 0, you can say, true or false, you can say. So yes or no. And the other type of classifiers are multi-class classifiers. Like I want to develop a classifier which will tell me the species of a flower. So I'm just in the garden, I'll just click an image and it will tell me. So if I give it to that classifier, it will tell me the name of that flower. Right? So this is multi-class classifier. So when there are only two classes, that means if I want to find out if a person is healthy or he's suffering from some disease, yes or no. So then there will be only two classes, that is binary classification. When there are more than two classes, it is multi-class classification. So based on this, when we see then one broad category of classifiers is binary or multi-class. Then we can also classify the classification algorithms as linear and non-linear classifiers. There could be tree-based classifiers, then artificial neural network-based classifiers. So there are different types of classifiers which are there. So with this brief introduction, there are three things. One is machine learning. when we are focusing on helping the machines make decision based on the information which is extracted from the data. That means it is machine learning. In machine learning, supervised learning means when a training data set has both the inputs and the desired outputs, and the teacher is training the model, it is showing it the correct output which it should give. If there is a mistake, then the weights change and it is getting trained, right? And then in this category, supervised algorithm, again, you can say there are two types, regression-based, classification-based. So when there are discrete classes, we are focusing on classification. When we are putting any input into a category, then it is classification. So now we will take a small example and we will see how this classification algorithms, they evolve. Like I said, machine learning, it focuses on statistical and probability-based techniques. From the symbolic representation, knowledge-based systems, in machine learning, they shifted on statistical and probability-based techniques, making use of the data and getting some information for decision making. So this I have taken from a book, this example that was very beautifully given. And in this case, if we take a simple, there are in the next figure, I'll show there are pieces of pie and Johnny likes or he does not like it. That means it is a binary classification problem. So there is positive and negative. So there are certain kinds of pies which Johnny likes, and there are certain kinds of pies which Johnny doesn't like. Right? So these are pieces of those pies. So you can't just train a model by seeing these images as such. Like I said, so I've taken this from this book, An Introduction to Machine Learning. So this was very beautifully and very simply given. So to be able to communicate the training examples to the machine, we have to describe them in some appropriate way. And that means feature extraction. The most common mechanism relies on so-called attributes, which we need. And in this, in the pi domain, so we suggest some kind of attributes which we can extract from these pies. And those attributes will be given to the machine for training. So in this case, in the pies domain, 5 may be suggested like shape. It is of different shapes like circle, triangle, and square. It has a crust size, either it is thick or thin. And it has a crust shade, like we see the crust is thick or it is thin. And its color is gray, white, or black. And then in the center, there is a filling. So filling size is thin or thick, and filling shade is again white, gray, or dark. So there is some kind of a filling which is dark, white, or gray. So these 5 attributes, they are taken. And based on these, we have these features. Okay? So we have shape, we have crust size and shade, we have size, shade, and then output is of 2 classes, either positive or negative. So from these 12 shapes, we are getting, for each shape, we are getting its features and we are specifying its output. Key, either Johnny likes it or he doesn't like it. So just give me a moment. I'll just be back in just a minute. टेम्परेरी तो सिंपलेस्ट ही है भी हम डोंगल्स लेके दे दिए एयरटेल के डोंगल्स सर अपन ऑप्टिकल लिंक भी तो लेके जाना पਊ मैं देख रही थी बिल्डिंग आपस भी तो ਕਿਹੜੀਆਂ ਇਕੱਠੀਆਂ ਉਹਨਾਂ ਚ
सिक्योरिटी कैमरास एक साइड पे
ਸਰ ਉਹਦੇ ਚ ਫਿਰ ਆਪਟੀਕਲ ਫਾਈਬਰ ਤਾਂ ਲੈ ਕੇ ਜਾਣੇ ਪਊ ਨਾ ਜਾਂ ਤਾਂ ਉਹਨੂੰ ਲੋਕਲ ਪਰਚੇਸ ਕਰਕੇ ਤੇ ਕਿਸ ਤੋਂ ਪਵਾਉਣਾ ਪਊ ਅੰਡਰਗਰਾਉਂਡ ਜਾਊਗੀ ਕੁਝ ਦੇਖ ਲੈਣਾ ਮੈਂ ਕਲਾਸ ਲੈਣਾ So I'm so sorry, it was a little urgent. So we'll continue. So in this case of pies, so we have these features and we have this output. So now what are classifier? We are going to train a classifier on these inputs. Ki whenever we get this kind of features, the output should be positive, and whenever I get this kind of features, the output should be negative. So how to solve this problem? So one thing is, now what in case we have a knowledge base in which I've kept all these examples. So there could be different combinations. And based now we have physically seen these pies and we know it is circular, it has a thick crust and it is gray in shade, but there are possibilities could be more. So there are three shapes. So 3 into 2, thick or thin. That means 6 possibilities are there if we consider it. Then this 6 possibilities, again, if they have shade as gray, white, dark, then 6 into 3 is 18. So 18 possibilities. And now for these 18 possibilities, again, there could be thick or thin. So 18 into 2, and again 18 into 2, and then you have the shade again, dark gray and white. So 18 into 6. So that is 108. So for these 5 attributes, we can have 108 different combinations, you can say. And there are 2 outputs, either positive or negative. So it is 2 to the power 108 different types of, in this case, subsets. So from these subsets, we want to find, we want to classify. So whenever we get these 5 attributes as input, if we use the brute force approach, then from all these, we will compare this input with all the subsets which can be generated using these combinations. So when the attributes size increases, this brute force approach cannot be used for finding the class to which this input attributes belong to. So the other way of doing it is the manual approach and search techniques. So in AI, you will study, in knowledge-based approaches, we studied that search formed an important part. So you have to search from the knowledge base. So in this case, instead of using the brute force approach, what we can do is we can use some shape. So if I see this and my input attributes are these: circle, thick, gray, thick, dark. So then I don't need to search it for other shapes. I can just focus on the circular examples. So I start with the circular, and then in this circular you will see, so this is circle, 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 and this is positive, positive, and this is also positive. But for this circle you will come see, and this circle, example 7 and example 10, that they are negative also. So if you will shortlist it based on the circle, so you will get 6 outputs. Out of them, 4 are positive, 2 are negative. But we want to classify it as either positive or negative. So in this case, we have to narrow down that. So I will write shape is circular and the filling is dark. So if I use a conjunction or an ANDing, so it will make it more specialized. But when I make it more specialized, it only gives me 4 positives out of the total 6. So 2 positives are left out. So that means now I have to generalize it a little. So shape is circular and the filling is dark, or the crust size is thick. So by ANDing, I had specialized it and I had taken only one attribute, that is dark. So now instead of taking dark, I take 2 attributes. Either the crust size is thick or it is dark. So out of these 2, any one is true, then the answer is true. So by doing this, I'm able to differentiate the 6 positives. So this is the manual search approach, where you are searching and you started with the brute force. In the knowledge base, you have everything stored and you compare it one by one to find out. But when the attributes increase and there's subgroups, they also increase. So there will be large number of comparisons which need to be done. So in this case, then we move towards searching. So search can be optimized. And then the earliest attempts to predict an examples class based on known attribute values was using the Bayesian probability. So another approach it moved towards, now we say from the symbolic approaches, we in machine learning move towards statistics and probability. So initially Bayesian probability theory was used. And in that case, we were using the prior probabilities, conditional probabilities, joint probabilities to find out or predict the class of an attribute. So there are some questions coming in the chat box. So I'll just respond to them once I complete this. So in case of probability-based approaches, so I know there are total 12 pies. Out of this, 6 are positive, 6 are negative. So I can find the prior probability of positive and negative as 6 by 12, that is 50%. In the same way, I know the number of pies with the thick crust is 8. Out of them, 3 have the output as positive. That means thick crust. And what is the probability, conditional probability that the response, it will be labeled as positive. That is 3 by 8, 37% chances. And the conditional probability when the crust is thick, that it will give me the negative. It will be treated as a negative class. That is 5 by 8. That is 62.5%. So based on this, if we classify it, that means thick filling has a greater probability to belong to the class negative than to the class positive. So in this case, makes sense that the classifier to label all examples with filling size thick as negative instances of pie that Johnny likes. So that means with the thick crust, there is a lesser chance that Johnny will like it. So they are put into the negative class. So we can use the probability theory for classifying. Like here, what is the chance that a player is going to play tennis today based on the outlook, temperature, humidity, and wind. So we will find the probability, prior probabilities, and the conditional probabilities, and then the joint probabilities for classification. So we won't consider it because we have limited time. Now we shift. So we had seen that one way of classifying is we can use the probability theory. But for probability theories, all these combinations or everything should be known in advance. Only then we can use it, right? But we say that our environment is changing and machines learn as the environments change. So this is not possible for all kinds of problems. So another type of thing is it is quite common that patients who have a similar kind of symptoms, they are suffering from a specific disease. So in short, similar objects often belong to the same class. That means if we can find the similarity between the input and different class objects belonging to different class. So we can label X depending on this similarity for a specific class. Whatever class it has the minimum distance, it will belong to that class. So K nearest neighbor rule or K nearest neighbor algorithm, it is based on this, finding the similarity between the input and the different classes. So similarity of an attribute vector, again, in this case, instead of the real objects, we get some kind of attributes and we compare those attributes, and whatever attributes match the best with the specific class, we put that input into that class. So in this case, normally we are using the Euclidean distance. Right?
Sir, it is.
We can use the Euclidean distance to find the difference between the attributes. Where the difference is minimum, we'll put it into that class. So like we have class A and we have class B, and this is a new example to classify. So we find its distance from all these objects belonging to two classes. So, and then in this case, K nearest neighbors. If I just take the single nearest neighbor, so this K1, that means this is the nearest neighbor and its class is A. So that means the input which we are having, we classify it as belonging to class A. So this is when we are considering only a single class. Sorry, I think I got disconnected. So in this case, we are considering only K is equal to 1. That means we are comparing it. We are finding the nearest only single neighbor. When now what could be the problem here? So in this case, if we consider the same example, and now I want to consider 3 nearest neighbors. So generally we keep K as odd, right? So in this case, voting happens. So this input has 2 neighbors from class B, which are close to it, and 1 neighbor from class A. That means the voting is higher for class B. There are 2 objects from class B which are shown as similar to the input and 1 from
ఎంత
class
పని
A.
చేసినా దానికోసమే కదా సార్.
So in this case, this voting takes place, and now this, in this voting, that means this input belongs to class B. And now the problem could be, in this case, the problem could be borderline cases. So now here, if we consider these 3 examples, 1 is clearly near to class plus, 2 is near to class B, you can say, if we consider this as class A, and 3 is equidistance from 1 and 2. Right? So in this case, this is the borderline case. So if there is a little bit of noise added to this input, maybe it will tilt towards plus or minus. So for such, the precision is, for borderline cases, it is low. And this 4 again, this 4, though it is in the class plus, but there is one noisy object here, which is shown as belonging to a different class, that is the second class. So if we consider only one nearest neighbor, maybe it will classify 4 as negative. But this problem is solved when instead of considering only one neighbor, we are considering 3, 5, 7 neighbors, and we use voting. So in case of voting, there are 2 plus neighbors near to it and only 1 negative. So it belongs to this plus class. So the issue, the problem with the noisy objects is solved when we are considering more than one neighbor and use the voting. And so sometimes the issue arises for the borderline inputs, which are equidistant from both the classes. And if there is some noise added, it can tilt towards a different class. Right? So that was in brief about how k-means clustering works. So first was based on probabilities, second was based in finding similarities, so they will be different classification algorithms, and normally they use Euclidean distance between the attributes to find how close they are. Like if we have these 4 examples and these are the attributes and these are the outputs as positive, they belong to positive class, they belong to negative class, x is the input. So we find the distance of x from each one of this, and the distance is minimum from example 2. Right? So if we are just considering a single neighbor. So if I consider the 2 nearest neighbors or 3 nearest neighbors, so then there are 2 which are positive and 1 is negative. Still they belong to the positive class. So we take the distance, and in this case, sometimes the problem arises due to irrelevant attributes. There are some attributes which are not very relevant, but they are contributing in misclassification. Right? And the second thing is key outliers. Some value may be very, very different from the others, like other values are 3, 4, 2, 5, and one value is 100. So this value, which is extremely large from others, will dominate. To suppress it, normally, whatever attributes are there, we normalize them in the range of 0 to 1. So some problems can be solved like this. So we had seen probability-based techniques. We should have a perfect knowledge of probabilities and their probability density functions. In k-nearest neighbor classifiers, they may suffer from sparse data where the data is very scattered and there are some irrelevant attributes and there is the scaling related problems which are there. So whenever we are studying any kind of classifiers, we have their strengths and their weaknesses. Now another approach is where we know that there are decision boundaries. One class is on one side, the other class is on other side, and there is some way we can divide that space into different subspaces based on the classes. So when representing the training examples with points in n-dimensional instance space, we may realize that positive examples tend to be clustered in one region and the negative examples are clustered in some different regions. So that motivates us for yet another approach in classification. That is, instead of probability and similarities, we can use decision surfaces. We can separate 2 classes using a line. So if these are, so this is a small gate operation we are taking, you can say. So when input x1 and x2, they both are positive, it is positive. And out here, they all 3 are negative. So in this case, we can separate this with the simple line. So one type of class is on one side of the line and the other class is on the other side. So this concept is used in neural networks. So we can use linear classifiers if our problem space is linearly separable. We can separate it using a line, plane, or a hyperplane. But always that is not possible. Right? So in that case, we will have to use non-linear classifiers. So if we see this problem, so if we separate it by a line, most of these objects of this class on this side, but one object is on this side also. This could be due to noise also, or it could be some rare event. That means it belongs to the other class only. So if we want to separate these 2 classes, we can't separate it with the line or a plane, but we need some kind of a polynomial. So when our data is very complex and scattered, then we are going to use the non-linear classifiers. So single layer perceptron is a linear classifier, but multi-layer neural networks, they can be made non-linear by adding hidden layers and non-linear activation functions. So now I think I'm left with only 2 minutes. So I'll stop here, though I wanted to discuss a little bit about decision trees also. So some classifiers, so that was similarity based, decision boundary based, probability based, and the last one, category of classification can be based on the decision trees also. So sometimes the classifiers, they do better by choosing attributes one at a time. So if I have 5 attributes, I will take the first attribute. Based on that, I will make a decision. I will move towards one side of the tree. So decision trees is another way of classification. So I'll stop here and I'll take up the questions. Like crust size, big or small. If crust size is big, we don't need to search in the small crust size. So I'll focus on only this part. Right? So this is decision tree based classification. So with this, we will stop. And so any kind of questions are welcome. So I think there are some in the comment section.
Okay, dear participants, if you have any queries, then ask to ma'am.
Haji, you
This
can
house
ask
is
me.
open for discussion now.
So though I had planned, but I think time was a little that you can. I think there are some questions, so I'll stop sharing and.
You may ask, you can unmute yourself now and you may ask. Please ask queries.
Haji, so
Good morning, sir and ma'am.
Haji, so I'll just take the questions from this chat. I think AI and machine learning can assist in pandemic-like situations most, as we realize it's important in COVID and more. Yeah, COVID, because even what we were trying to do in COVID test also, we can make use of X-rays. Because you have X-rays of a person suffering from a normal pneumonia and COVID. So if you train a machine learning algorithm on this data, so when you give a patient's X-ray or CT scan, it is going to find out if it is a normal pneumonia or it is COVID. So there are a number of ways in which we can use it. And become research oriented and scientists. See, machine learning and AI is giving us all opportunity to become research oriented and scientists. Yes, if we have a large amount of data, and this data can help us in generating knowledge. So we are knowledge based economy, but in machine learning and AI, I think there are many issues also. Ethical issues are also, if our data is biased, it won't give us the correct results. So it's very, very important that our data should be good, of large size, and it should not be biased in any way. Otherwise, our machine learning algorithms, they are not going to give us the correct results. So even in AI, like if we have self-driven cars, so there are certain issues. If there is an accident, who will be responsible? If a artificial intelligence agent makes a mistake, so all those issues are also there, but otherwise it has helped a lot in critical areas like medical imaging, cybersecurity, and things like that. So those things are there. So any other question is welcome. So I think only these two are there.
Which algorithm is suitable for classify cancer images, ma'am?
You're asking which classifiers are good for?
Classifying cancer images.
See, in this case, we use deep learning models like deep neural networks. Convolutional neural networks are good, because in that case, initially what we were doing, we were taking the images, then we were finding some features like we were movement features, or we were using angular radial transform, or we were using wavelets, and they were not suitable for different kinds of images, and feature extraction was itself challenging. So now deep neural networks like convolutional neural networks, they take raw images. And if you have good machines, you can just train them, but your data size should be large. So the main issue which comes is in medical imaging, your data size, it's very difficult to gather a data size of large size. because of the personal information of patients. So in COVID, they shared a lot of data on GitHub. All the researchers were sharing. So now we have a large data set in that. So that way it is good. At least 5,000 or more images if you have, then you can use this deep learning methods.
Thank you, ma'am.
Thank you.
Ma'am, very good morning.
Good morning, sir.
Very good morning. Ma'am, is a support vector machine is more suitable, SVM is more suitable than decision tree for classification of diseases from images.
Sir, if you
image data set we have, and from that we want to classify the disease. It may be a herpes is there or not. So
Okay.
support vector machine is more suitable than decision tree, or we apply both, and from that we find out accuracy.
Sir, I think SVM is more commonly used in medical imaging, you can say. But it will depend on the kind of features which you're extracting. Because if you're using SVM or decision tree, like I've said, in decision tree, what you need to, you will take one attribute and then you will take the next attribute, right? So when you talk about medical imaging, we get the attributes, like we get features, like we find the wavelets. And we use the wavelet coefficients. So all these attributes are coefficients only. So in that case, SVM will be better, because in decision tree, you take one attribute and then based on that, you move, right? But in certain other applications where you have different features, like you have weight, height, like we want to see the child growth with different types of diet and exercise. So exercise is one attribute, food is another attribute. So in this case, decision tree will perform better. You take maybe their eating habits first, and then you see how much exercise they do. So that way decision trees will perform better. But in medical imaging, I think SVM is going to be more suited, because we have similar kind of features only. Maybe we are finding movements, then they are movement, or we are getting some spatial domain features like color features, shape features. So there's we are having only one kind of attribute, you can say.
Thanks a lot, ma'am. Thanks.
Thank you, sir.
Any more queries, participants? Please ask. House is open for discussion still.
Ma'am, for detecting edges in an image, we use statistical method. Yeah, ma'am. We want to detect the edges in the image. For the purpose,
you want to find the edges in the image? Hanji?
Yeah, ma'am. For that, what type of statistical approach we use to find that accurate size of the images?
You want to find the edges from your image, na?
Yeah, ma'am.
So edges can also be found using either spatial or transform domain techniques. Like if we are using spatial domain techniques, we basically use gradients. So wherever there is transition in gray level, we use first order or second order differential equations, you can say. So based on that, like we have canny edge detector and Sobel operator and all those. Or we if we find the wavelets, then it has the different coefficients, detail coefficients. So through detail coefficients also we can find the edges, and edges can also be found using fuzzy logic. We have membership functions, and based on the fuzzy value which we are getting, we can do it. So and there are different techniques. Mathematical morphology can also be used, where you have a structuring element and you do erosion, deletion, or closing, opening, and their combination, you can find the edges. So large number of techniques are there to find the edges, but statistical techniques, like simple techniques we use, mean, variance, and all, that is to find the effect of noise. So when I do denoising, I'll find the mean value. It should be retained, whereas the variance should decrease. So if the noise is suppressed in the images, or otherwise also we use other statistical techniques also, like the type of noise we want to find out. Then we can take the image histogram, and the shape of the histogram will tell me the type of noise which is there. So we can do like that.
Okay, thank you, ma'am. Thank you so much.
Okay.
Any more queries? Okay. Indeed, ma'am, it was a very great and interactive and very informative lecture. I hope that our participants have learned a lot of things and they will definitely implement these things in their research. Now, I would like to call my colleague, Dr. Nayan P. Bhosle, to propose a vote of thanks to ma'am.
Thank you.
Thank you, Pawan sir. Am I audible?
Yeah, right.
Actually, I would like to ask one question to madam, then I will do my job.
Hanji, surely, sir.
According to me, madam, while we are talking about to denoise the images, I think we having 6 histograms. Based on that, we can identify with the help of statistical measure. But at the same time,
histogram, that can be done.
Beyond that, there are different noises. To rectify them with the help of statistical measure is a quite difficult job. So we required, and I think there are too many researchers, especially according to me, ISRO, NASA peoples are very much eager, and they are working very parallelly too hard, because after all, I think first step to every research is the cleanness of the data.
So that is there.
Too much you pointed the detailed feature we require. So can you specify one or two names which can be useful of to detect the traditional? I'm not talking about traditional noises, but some other ultra modern types of noises, please.
Features which can be used, sir?
I mean, features would be anything, but the type of noise is not traditional. Apart from traditional noise type, we having different noise types. Then how we can do the classifications?
Sir, in this case, like you're saying, we have Rician noise, or we have poisons noise, or we have combination of noises. Sir, there are two things. Either we go for image restoration. Image restoration is when we exactly know we can model that noise. So that is based on histograms and all. Otherwise, like in medical imaging, where we have a combination of Gaussian and multiplicative noise or speckle noise. So, sir, if you will see now, a lot of work is being done on non-local means filters. So they are giving quite a good result for medical images also. But in that case, we have to add one term that is called the bias term. That is based on the variance of the noise. So if we are able to calculate that variance from the noise, and I apply non-local filter, and then I subtract that bias term from there, so it gives good noise for even combination of noises. So that is very widely used instead of non-local means filters. Only problem is computationally complex, but now they are using integral images in that. That has made it a lot fast. So that is one of the benchmark techniques for noise suppression.
Thank you, madam.
Thank you.
I think indeed it is a quite very interesting area to do a research on any front, especially classification. Thank you, madam. So I would like to thanks Professor Amandeep Kaur madam for the accepting the invitation and delivering the beautiful session. So I observed the entire session. Madam discussed various technical points like borderline class as well as decision theory. So apart from that, I would like to just mention two important points, like whenever we having complex data and scattered data, we may choose a non-linear techniques, statistical measures to do rectify and reach at the hidden level data. Apart from that, whenever we're having a normal data, we will go for the linear one, statistical measures. That was the very interesting things which pointed before the all audience. And really, I think doing a classification of any data is a challenging task. And you have delivered all the notions and the views and measures in your fantastic way. So, on behalf of the entire organizing team of the IGNTU Department of Computer Science, I would like to sincerely thanks for your contribution in our workshop. With this, I would like to once again thank you to you, ma'am, and definitely we wanted to invite you in an offline program also. So you be ready for the same.
Sure, please.
Thank you very much.
Thank you so much for inviting me. It's always a pleasure discussing things and sharing it.
Thank you so much. Really, it was a very good session, very good interactive session.
Okay, sir.
Thank you so much. I have one request. Please share your PPT so that I can share.
Surely, sir. I'll share it. Sure.
And I'm sending you a honorarium receipt also. Please sign it and send to me.
No problem.
Thank you so much. Have a nice day, ma'am. Thank you.
Okay, sir.
Thank you. Okay, dear participants, if you have any query, you can ask to me. 5-6 break also. After that, we will meet at 11:20.
Madam, reviewer only ना madam.
बस एक सीडी है, बुक्स हो गई है, बस एक सीडी है, वो मैं कर लूंगी। बुक तो हो गई, सारी बुक्स हो गई।
Yeah, participants, we will meet at 11:20. We have 5-minute tea break. Okay. Now at 11:20, with us we have Professor Vikas Parikh from Central Institute Bihar. Okay. Fill the attendance.
Sir, we'll join at 12. I think 11:20 na.
5-6 minutes after. Okay.
Thank you, sir.
विकास सर, मेरी आवाज आ रही है आपको?
जी, मुझे आ रही है। आपको मेरी आवाज आ रही है?
हाँ, आपकी आवाज आ रही है सर। आप जरा वीडियो ऑन कीजिए। हाँ सर, नमस्कार सर। I think there is some network issue. Let me check.
ఓకేనా మేడం? మీకు ఆ రోజు చెప్పాను కదా ఇక్కడ చేసేటప్పుడు. నేను మీరు చేసేటప్పుడు చెప్పాను కదా మేడం. సర్టిఫికెట్ చేస్తున్నాను మేడం మీకని. I am doing certificate for you అని చెప్పాను నీతో ఆ రోజు నేను.
Okay, Vikas sir, are you there?
Yes, I'm there. Can you hear me?
Yeah, I can hear you clearly, sir. Because there was a submission network, I have switched the network. I switched to the Geo. It was University Network and can. भोसले सर आपकी आवाज नहीं आ रही. भोसले सर.
लास्ट टाइम भी नहीं आ रही थी सर.
हाँ अब आ रहा है. ओके.
थैंक यू सर.
ओके.
सर को नमस्कार सर.
विकास सर आपके नेटवर्क में आई थिंक कुछ इशू लग रहा है मुझे.
हाँ थोड़ा सा लो है सर का नेटवर्क.
मैं मोबाइल से बोलता हूँ. अब आपको मेरी आवाज आ रही है?
हाँ आवाज आपकी बड़ी अच्छी आ रही सर.
जस्ट अ मिनट, मैं इधर से म्यूट कर लेता हूँ.
जी.
देखते हैं मोबाइल से चलेगा तो हम मोबाइल से ज्वाइन कर लेंगे.
हाँ आप स्क्रीन किससे शेयर करेंगे सर? इस पे अच्छा आ रहा है.
स्क्रीन में लैपटॉप से शेयर कर देता हूँ.
हाँ प्लीज, क्योंकि फिर मोबाइल में बड़ा छोटा स्क्रीन आता है तो फिर उसमें वो विजिबिलिटी में इश्यूज होता है.
ठीक है.
जी. मैंने आपको प्रेजेंटर बनाया. अब दो जगह से ऑन होगा. नहीं ठीक आ रही है, एकदम क्लियर आवाज है सर.
एक सेकंड.
नीरज सर को नमस्कार.
हाँ सर बड़ा अच्छा दिख रहा है. आप बस स्लाइड शो स्टार्ट करेंगे तो. विकास सर इट इज गुड. अच्छा दिखाई दे
रहा है. हाँ सर मोबाइल से इधर से आप अच्छा दिख रहे हैं, उधर स्लाइड भी दिख रहा है, प्रॉपर दिख रहा है सर.
हाँ इट इज गुड सर. ओके आई थिंक शुड वी स्टार्ट इट्स 11:20.
कितनी देर में स्टार्ट करेंगे?
अभी स्टार्ट कर रहे हैं सर. 11:20 हो गया आई थिंक.
एक मिनट.
जी.
टाइम इज ओवर.
नीरज सर वो मेल करना है ना?
जी.
कौन सा वाला?
वैलिडेटरी मेल कर दूं?
हाँ कर दीजिए. It's up to you. If you want to send to all, then okay. Otherwise, no need to send.
It's a tradition. We will send to everyone. If we are doing something, why not we should tell everyone?
Okay. No issue. You can do.
आज ये यूनिवर्सिटी वाला नेट नहीं चल रहा है. मैं अपना ही चला रहा हूँ.
कौन सा चला रहे? जियो चला रहे या एयरटेल चला रहे?
जियो.
सो जियो सर.
ये मोबाइल में थोड़ा इशू हो रहा है. एक बार लैपटॉप वाला मेरा ऑन करेंगे प्लीज.
लेट मी चेक सर. वेट फॉर 1 मिनट सर. वेट सर. आपका लैपटॉप में ओके.
मुझे अनम्यूट कर लेता हूँ.
जी मैंने रिक्वेस्ट. हाँ सर जी.
अब मेरी आवाज आ रही है वहाँ पे?
हाँ बिल्कुल सर. लेकिन आपका वीडियो दिखाई नहीं दे रहा है. ठीक है कोई बात नहीं. अगर वीडियो भी नहीं चल रहा है तो दैट इज गुड, क्योंकि ये काफी नेटवर्क बैंडविड्थ.
लेकिन सर की आवाज की क्वालिटी मोबाइल से बहुत अच्छी आ रही है सर, और इधर से लैपटॉप से ये स्क्रीन भी अच्छी दिख रही है. तो सर को जैसे कंफर्टेबल है वो ऑप्शन को ऑप्ट करने को बोलिए सर. पवन सर.
जी.
एक्चुअली मोबाइल से ज्वाइन करने पे इको की प्रॉब्लम आ रही है. इसमें आवाज मोबाइल से ठीक आ रही है.
हाँ सर आपकी आवाज मैं अच्छे से रिसीव कर पा रहा हूँ
सर. दोनों से अच्छी आ रही है. जिसमें
कर दीजिए.
ओके. आप जिससे चाहे सर उससे कीजिए.
हाँ
लेकिन ये मैं आप लोगों को सुन नहीं पा रहा. मुझे आपकी आवाज थोड़ी लैपटॉप पे अच्छी आ रही है. इस पे स्पीकर का कोई ऑप्शन होता है?
गो विथ लैपटॉप सर, दैट विल बी बेटर.
ओके.
लैपटॉप में हेडफोन इस्तेमाल कर लीजिए सर. दैट विल बी गुड.
हाँ.
अरे दिक्कत है. ये सरफेस प्रो है, इसका हेडफोन नहीं है मेरे पास. ये थोड़ा सा
सर ये कर सकते हैं कि आप लैपटॉप से स्लाइड स्टार्ट कीजिए और मोबाइल से बोलिए सर, अगर कुछ इश्यू है तो। Vikas sir, are you there? Yes.
Yes, I am there.
Your voice is good, sir. Okay, should we start?
Yes. As you wish.
Okay. Good morning to one and all over there on our WebEx platform who are joining this workshop, international workshop on machine learning and in its application organized by the Department of Computer Science at IGNTU Amarkantak. Today with us we have Professor Vikas Parikh from School of Computational Sciences and ICT, Mahatma Gandhi Central University, Bihar. Now I would like to call my colleague, Dr. Narayan Bhosle sir, to introduce Professor Vikas Parikh sir. Please, Dr. Bhosle.
Thank you, Pawan sir. So, Honorable Speaker, Professor, dear participant, it is my great pleasure to introduce today's session speaker. Welcome, sir. Professor Vikas Parikh is the Dean, School of Computer Science and ICT, and Head of the Department of Computer Science at Mahatma Gandhi Central University, Bihar, India. He is a rich experience in academics and academic administration. Along with that, he has been served as a OSD of Finance. He has been working with Mahatma Gandhi Central University since its inception from 2016. He has published many research articles on various reputed journals. Along with that, he has more than 17 years of teaching experience and research. Professor Parikh has supervised numerous research scholars and software development projects. He has also worked as a coordinator for the Center of Cybersecurity at MGCU. He has served on TPC and editorial board of many conferences and workshops. He is a life member of Cryptographic Research Society of India and Indian Science Congress Association and various professional bodies member, ACM, Rotary Club, etc. His research interests include cybersecurity, e-learning, and computer and security. And he's a very vast reader, and he has a very deep interest in philosophy and Indology. So with this brief bio sketch, I request to Professor Saab, so please take the charge of session. Over to you, sir. Thank you.
Thank you, Narayan sir.
So much. Thank you. Am I audible?
Yes, sir. Yes, sir. Please go ahead.
Okay, thank you. So, friends, first of all, I am thankful to the Department of Computer Science at IGNTU for inviting me as a resource person in this prestigious workshop. And before I start my talk, let me tell you that I am not an expert of machine learning, and I have a peripheral interest in machine learning. I have been working in this
Sir, you
area
may
for
mute one of the
cybersecurity.
device. Vikas sir, you may mute one of your device, means either headphone, mobile or laptop, because
Okay, so I don't see the option of muting on the laptop. Just a minute. You please mute my laptop.
I have muted, sir. I have muted your laptop, sir. You go ahead, please.
So now
it is good, sir.
Now
It
is the voice
good now.
clear?
It is clear, sir. Please go ahead.
Is it clear now? पवन सर क्लियर है ना?
आवाज आपकी क्लियर है सर, लेकिन दो डिवाइस पे अभी पे आपको दिखा रहा है, फोन पे और मोबाइल पे। किसको इसमें सॉरी लैपटॉप
कीजिए, मोबाइल को म्यूट कर दीजिए और उसके बाद बताइए आवाज कैसा आ रहा है।
सर मैंने रिक्वेस्ट भेजा, आप प्लीज उसको, हाँ हो गया सर, यहाँ से म्यूट हो गया। आप प्लीज अब आप कंटिन्यू कीजिए सर। विकास सर, मेरी आवाज आ रही है आपको? विकास सर, आर यू देयर?
दोनों म्यूट कर दिया तुमने.
I am there.
Okay, okay.
Is my voice audible?
Yeah, it is audible, sir. Please go ahead.
Okay, thank you. So, well, I was saying that I have a special interest in information security and cyber security as such. And recently, I have also started to learn about machine learning. And in fact, you have invited me for this talk in this workshop on machine learning. So I thought that I should share some ideas about relationship of machine learning for security. Well, first of all, there are some basic terms related to cybersecurity. Of course, because there we have had already a number of sessions on machine learning in this workshop, and I assume that most of the participants are also, well versed with concepts of machine learning. So I am not going to
Dear Vikas sir, your voice is not coming. Vikas sir? I think there is issue in laptop.
Am I audible now?
Yeah.
Okay,
You are
so
audible, sir.
so you do one thing, you mute me on the laptop. I will be
Okay,
continuing through mobile.
Okay, you are muted on laptop, sir. Please go with mobile, sir.
Is it all right now?
Yeah, it is good, sir. Please go ahead.
I'm sorry, there is some issue with the Wi-Fi here at LGCU. Anyway, so I was saying that I assume here that most of you are already experts and are aware of the concepts of machine learning. So I'm not going to discuss about machine learning concepts, but about some concepts from cybersecurity, and then we will see what are the some application areas where we can apply concepts of machine learning in security. Well, as the definition goes, this is IBM's definition. Cybersecurity is the practice of protecting critical systems and sensitive information from digital attacks. Also known as information technology security, cybersecurity measures are designed to combat threats against network systems and applications, whether those threats originate from inside or outside of the organization. So here we are concerned with not only insider attacks and threats, but also outsider threats. Why this echo issue is there?
No, not too much, sir. It is quite audible. Please, okay. Please
Okay,
continue,
thank
sir.
you. Thank you. So this is the Nist cybersecurity framework. Well, in cybersecurity, although we have many different, a lot of terms related to cybersecurity, and it is a vast discipline, but there are some basic concepts which are there always whenever you think about security, and you all might be aware of the CIA triad, and that is the confidentiality, integrity, and availability. So there are actually two approaches to cybersecurity. One is thinking in terms of threats and attacks, and another is in terms of providing certain services. So these are two views. One is to protect your system from internal or outside threats and attacks, and another is to be able to provide certain services. That is the affirmative view of cybersecurity. So NIST defines a framework. The National Institute of Standards and Technology defines a cybersecurity framework, and there are certain
Vikas sir, please unmute yourself. Yeah, it is good.
Okay. But please resolve this echo problem because I feel a bit
No,
awkward.
there is no echo, sir, now, because no, there was somebody who was disturbing, so I have muted it. There is no echo, sir. There is no echo.
So now is it clear?
It is good, sir. It is good.
Okay, thank you. So there are basically three approaches of security: prevention, detection, and response. And we will see that in all the three areas we have applications of machine learning. Prevention, as they say, is better than cure, because prevention is about being able to and there are certain vulnerabilities in the system also. So we will think about all these aspects when we discuss about it. Now, what are the different cybersecurity attacks and risks? There is this. Just a minute. Just a minute. Mute, please. One risk is possibility of unauthorized access that describes the act of accessing information to network systems or data without authorization that results in a violation of a security policy. That is one possible attack scenario of unauthorized access. We also call it intrusion. Then another possibility is of malware, which are basically malicious software, which is any program or software that intentionally is designed to cause damage to a computer, client, server, or computer network, for example, botnets. Examples of different types of malware include computer viruses, worms, Trojan horses, adware, ransomware, spyware, malicious bots, etc. We all are familiar with the ransomware, which is an emerging form of malware that prevents users from accessing their systems or personal files or the devices, and then demands an anonymous online payment in order to restore access. Then there is this denial of service attack. Now you can efficiently work on other attacks, that is attacks that I have described earlier, like viruses and malware, by using certain strategies like using antiviruses and firewalls. But there is an attack which is very difficult to handle, especially when it is in the form of what you call the distributed denial of service attack. So denial of service is an attack which is meant to shut down a machine or network, making it inaccessible to its intended users by flooding the target with traffic that triggers a crash. Is actually to overload your system so that you are not able to provide a service. So denial of service attack typically uses one computer with an internet connection, whereas in distributed denial of service attack, multiple computers are used and internet connections to flood the targeted resource. Then there is phishing, which is the type of social engineering which is used for a broad range of malicious activities accomplished through human interactions, in which the fraudulent attempt takes part to obtain sensitive information such as banking and credit card details, login credentials, or personally identifiable information by disguising oneself as a trusted individual or entity via an electronic communication such as email, text, or instant message, etc. We all receive such phishing emails. So there is an issue of spam filtering, where we have a lot of applications of machine learning. Zero-day attack. Zero-day attack is considered as the term that is used to describe the threat of an unknown security vulnerability for which either the patch has not been released or the application developers were unaware. So that is a possibility. There is this competition between the developers and the attackers, and whosoever identifies this vulnerability first will win. So that is known as zero-day attack. Now, machine learning, as you all know, is the study of computer algorithms that can improve automatically through experience. Build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. And you might all be aware of the types of machine learning. Reinforcement learning. So I skipped this part because in this workshop you might have already be aware of this these types of machine learning algorithms, the different categories of machine learning algorithms. We will come back to this data sets later. And this is the classification of the taxonomy of machine learning algorithms, which are classified either as shallow model or deep learning model. And as we discussed earlier, we have supervised and unsupervised learning, and the different algorithms which fall in the category of supervised and unsupervised algorithms. You might all be aware of these different algorithms. Now it comes to machine learning approach to cyber threats. Well, there are two different areas, ML and cybersecurity. In cybersecurity, we are concerned with protecting our digital infrastructure, or what you call your cyberspace, from internal and external threats. This is one way of defining it. And another, as I said, is to be able to provide certain services like confidentiality, integrity, availability, non-repudiation, these services. Now, when we use machine learning algorithms for cybersecurity, this becomes a very interesting case. There are two approaches. One approach of cybersecurity is the traditional approach, in which what we have is we kind of we use reactive approach. That something happens, we are made aware of it, and then we take some corrective measure. But when you use machine learning approach, you have your what you call predictive analytics. You can in advance you can predict what can be the possible malware, what can be the possible attacks. We can identify them in advance, and we can take some preventive measures in the advance. So when you say machine learning approach to cyber threats, the different threats are there, like what you call information gathering or sniffing. Different kind of intrusions are there. Intrusion attempts like login, fraud, for example, phishing emails, we are all aware of that. Then abusive content in form of spam is also possible. Different kinds of malware, as mentioned earlier, for example, viruses, and availability attacks, for example, distributed denial of service attack. So different kind of threats are there in the cyberspace. And the different components which may be affected are the network, the endpoint, applications, and the user. What are the possible objectives or the actions that we can take are, as we mentioned earlier, prediction. Now here ML will be very helpful to us in predicting the possible threats and vulnerabilities in advance. Detection of any kind of intrusion or any kind of attack to our system. Prevention, response, that how do you react to such a situation, and monitoring. So these are the objectives which we want to achieve with the machine learning: prediction, detection, prevention, response, and monitoring. The different ML methods which are useful for our cybersecurity objectives are anomaly detection. We use the statistical anomaly detection and other kind of anomaly detection in intrusion detection systems, or IDS. Pattern recognition, supervised learning, that is classification, and unsupervised learning, that is clustering. Then if you compare the machine learning approach versus the traditional methods in cybersecurity, as I mentioned, in traditional methods of cybersecurity, we are using a reactive approach. That is, when something happens to our system, then we take some kind of corrective measure. It is static rules based. Whereas in case of machine learning, we use a dynamic approach which keeps improving by learning. Plus, in traditional, we target known attacks. We are aware of certain kind of attacks and then we target them. Whereas in machine learning, we have the capability of recognizing new abnormal patterns. Traditional approach is prone to human error, whereas machine learning approach is claimed to be efficient and automated. So if we look at this figure, using machine learning algorithms on network traffic data, programming code or binaries, and scripts, what we do is we extract features. We perform feature extraction. And from that, we detect certain threats, attacks, and vulnerabilities from the system. And accordingly, we take some decision of generating alerts or blocking certain processes. So this is the, you can say, a model of using ML for cybersecurity. Now, it is very important because in traditional approach, what happens is you have certain kind of attack. For example, your system is infected with a virus, or your or there is some kind of intrusion or unauthorized access to your system, and then you as your input you have network traffic data. We have the data packets, so we have traffic data. We can analyze the traffic data, and whenever we discover or observe some aberration or some abnormality or some kind of anomaly, then we can predict that there is certain kind of there is a possibility of some kind of intrusion. Plus, program code or binaries can also be observed. We can also look for signatures of certain malware, and we can, accordingly we can block the that process, or we can issue an alert. Now, three important areas have been identified where we can apply machine learning approaches to cybersecurity. As I mentioned, intrusion detection is one part, malware analysis is the second part, and spam detection. These are the three areas where already machine learning algorithms have been applied heavily for the different kind of intrusion detection systems, for example, the network intrusion detection systems, and for malware analysis and spam detection. Intrusion detection. Now, intrusions are actions that attempt to bypass security mechanisms of computer systems. They are caused by attackers accessing the system from internet, and insider attacks, authorized users attempting to gain and misuse non-authorized privileges. Now there is a new paradigm which is emerging these days. I was part of a committee of the Government of India which worked on what you call ZTA, Zero Trust Architecture. Because in our traditional model, what we do is we assume we provide certain privileges. We authenticate users and systems, and we provide them, unlimited access within their domain. For example, and that leads sometimes to what you call insider attackers. But now they are working in the direction of what you call zero trust, where you don't provide trust where you don't give unrestricted access on the basis of the login, but you provide access. You don't trust any system, or you don't trust any user or any process, and you are very specific about what kind of privileges or what kind of access is to be provided. Every time you access, you try to you request access to some resource, then system does not assume any prior trust, and you have to be authenticated every time for that. Now, intrusion detection is the process of monitoring the events occurring in a computer system or a network and analyzing them for signs of intrusions. As I said, there are three approaches: prevention, detection, and response. Prevention is not normally possible. Detection is something which is extremely important in security, that you should have an ability to detect if something malicious is happening to your system. And where this is where intrusion detection comes in the picture, that you monitor the events which are occurring in your network or in your system, and you continuously analyze them for signs of intrusions, which are defined as attempts to bypass the security mechanisms of a computer or a network, which actually compromise the confidentiality, integrity, or availability of information resources. Here, in this particular area, that is intrusion detection, we have a lot of applications of machine learning. Then comes malware analysis, which is the study or process of determining the functionality, origin, and potential impact of a given malware, such as a virus, worm, Trojan horse, rootkit, or backdoor. Now here you have a lot of applications of what you call supervised learning. You have a lot of training data. You have a lot of samples of known malwares, and using them you can train your system to identify, to detect signatures of possible malware, and you can do malware analysis. And spam detection, which is detecting unsolicited and unwanted emails. Now we can take examples of certain products and services which are there available for security, which make use of machine learning approaches. One good example for AWS is Amazon Macy. Now this is related to Amazon's cloud service AWS, and Amazon Macy enables it is enabled with one click in the AWS management console or a single API call. It continuously evaluates S3 environment, automatically generates an inventory of S3 buckets and details on the bucket level security and access controls, discovers sensitive data, analyzes buckets using machine learning and pattern matching to discover sensitive data, such as personally identifiable information, and takes action to generate findings and sending to Amazon CloudWatch events for integration into workflows and remediary actions. Now, Amazon Macy is a fully managed data security and data privacy service that uses machine learning and pattern matching to discover and protect your sensitive data in AWS. As organizations manage growing volumes of data, identifying and protecting their sensitive data at scale can become increasingly complex, expensive, and time consuming. Amazon Macy automates the discovery of sensitive data at scale and lowers the cost of protecting your data. It automatically provides an inventory, as I mentioned earlier, including a list of unencrypted buckets, publicly accessible buckets, and buckets shared with AWS accounts outside those you have defined in AWS organizations. Then Macy applies machine learning and pattern matching techniques to the buckets you select to identify and alert you to sensitive data, such as personally identifiable information. Sometimes what happens is there is a lot of data which is shared and stored in the cloud, and there is some certain part which is very sensitive. For example, suppose there is your banking data, and in that data there can be your confidential details, or suppose your profile is shared and in that profile there is certain data which is crucial, which you can say personally identifiable information, which can be related to your Aadhaar details or your other details which may be of confidential nature. So Amazon Macy it uses machine learning approach because the data is huge and that is there in the cloud, and Amazon Macy applies machine learning methods for separating and tagging what you call PII, or the personally identifiable information, and accordingly it tries to identify which services or which programs are trying to use that sensitive data, so alerts can be generated. So Macy automatically detects a large and growing list of sensitive data types including personal identifiable information such as names, addresses, and credit card numbers. The service also allows you to define your own custom sensitive data types. So you can discover and protect the sensitive data that may be unique to your business or use case. You can also define that this particular feature or this particular data is sensitive, and the Amazon Macy program will identify if there are any threats related to that sensitive data. Then there is this AI2, MIT and Perimeter X, where they use both unsupervised and supervised learning. And this is experiment of MIT and Pattern X. After clustering, the data is labeled by an expert. Clustering, which is unsupervised learning, that is applied, and then the data is labeled by an expert. Eventually, that turns the task into supervised learning. This is another example which you can refer to. Then there is this very important, this JAS, which is a network anomaly detection program, which uses both unsupervised and supervised learning. JASC leverages machine learning. This is a company which provides services related to security based on machine learning. JASC leverages ML for anomaly detection of network activity. What is good about JASC? They have their blog and a lot of details about there, which provide, you can further read about JASC on this. And Perimeter X provides anti-bot protection. It's a SaaS solution where the machine learning is used to calculate a score of risk, whether there is a bot or not. And then so we discussed about some approaches which were there, which are used where we use machine learning where we use machine learning for cybersecurity applications. There are some other possibilities also where we can use it, and we will discuss about that also. Now, as the ML and this is continuously growing, the attack techniques are also becoming more and more sophisticated in penetrating systems and evading generic signature-based approaches. Now, machine learning techniques offer potential solutions that can be employed for resolving such challenging and complex situations due to their ability to adapt quickly to new and unknown circumstances. Diverse machine learning methods have been successfully deployed to address wide-ranging problems. Now, the different areas where we have applications are, one, I mentioned phishing detection, then network intrusion detection, testing security properties of protocols, authentication with keystroke dynamics, cryptography, human interaction proofs, spam detection in social network, smart meter energy consumption profiling, and there are certain issues of machine learning techniques itself. There is an interesting example. We all are familiar with the CAPTCHA, which is used to ensure that automated entries are not there. So CAPTCHA was used, and which is known as human interaction proof. There is a paper by some authors which show how the human interaction proofs or CAPTCHA also can be broken by utilizing machine learning. So machine learning not only helps you in securing the systems, but it also helps attackers in attacking your systems. So in that particular example, they propose to locate the characters, the segmentation step, and employing neural network for character recognition. So in fact, it was successfully used, the system was successfully used to break the CAPTCHA system. So human interaction proof or CAPTCHA system can also be attacked by using this. And Then there are cryptographic approaches also, which are based on machine learning. A fast and efficient cryptographic system was based on delayed, chaotic, hope-filled neural networks. And the researchers showed how two synchronized neural networks can be used for a secret key exchange over a public channel. We have traditional methods of secure key exchange like Diffie-Hellman's key exchange algorithms. Plus, we have public key algorithms for secure key exchange. But some ML applications using neural networks have also been established, where they perform secure key exchange using chaotic maps. Plus, there is application of social network spam detection that where we can use machine learning algorithms. So machine learning is an effective tool that can be employed in many areas of cybersecurity. There exist some robust anti-phishing algorithms and network intrusion detection systems. Machine learning can be successfully used for developing authentication systems, evaluating the protocol implementation. Although machine learning facilitates keeping various systems safe, the machine learning classifiers themselves are vulnerable to malicious attacks. That is also important to understand. There have been some work directed to improving the effectiveness of machine learning algorithms and protecting them from diverse attacks. So there are many opportunities in information security to apply machine learning to address various challenges to such complex domain. Spam detection, virus detection, and surveillance camera robbery detection are some of the examples where we can use machine learning algorithms. Plus, there are certain issues also which are related to security of machine learning systems themselves. Security of machine learning systems. So far, we have discussed about the various areas where we can use ML algorithms for providing security, but machine learning systems, ML systems themselves have certain, vulnerabilities and certain, possibilities of attacks. There can be causative attacks which alter the training process, because in the machine learning we have an important step of training, and if that is compromised, then our ML system can be misled into something malicious. So that is known as the causative attacks which alter the training process. There can be attacks on integrity and availability, making false positives as a breach into the system. There can be exploratory attacks which exploit the existing vulnerabilities. There can be targeted attacks which are directed to a certain input. Indiscriminate attacks in which inputs fail. So there are also possibilities. The defense that is prescribed for these attacks is an attacker can create evaluation distribution that the learners predict poorly. For defending against this attack, the defender can limit the access to the training procedure and data. You will have to make sure that your training procedure and data is provided limited access so that it is hard for an attacker to apply reverse engineering. Also, the more complicated a hypothesis space is, the harder for an attacker to infer the learned hypothesis. In addition, a defender can limit the feedback given to an attacker so that it becomes harder to break into the system. An example of the applying the defensive algorithm, the researchers simulated attacking the spam-based spam detection system and showed the effectiveness of the system against indiscriminate causative availability attacks. So we also have to be familiar with the different possible attacks on the ML systems. Plus, there are certain important data sets which are important required in your machine learning application. There are certain important data sets which you require for training your system and for your work, be it related to spamware detection or anomaly detection. The important data set is a DARPA, which is an intrusion detection data set that includes LLDOS 1.0 and LLDOS 2.0 to attack scenario data. there is this KDD99 cup, which is most widely used data set containing features for evaluating anomaly detection methods, where attacks are categorized into 4 major classes, such as denial of service, remote to local, user to remote, and probing.
Dear Vikas sir, voice is not coming. Vikas sir? Vikas sir, voice is not coming. Vikas sir, voice is not coming. Vikas sir, your voice is not coming. Vikas sir, your voice is not coming. Please unmute yourself.
Is it not audible to you?
Now it is coming. You were muted. Okay. 2 minutes before.
So now these were the different cybersecurity data sets. And with this, talk is over. If you have any queries related to this, you may kindly ask. So this is over from my side. If anybody has any questions, you may please discuss.
Okay, dear participants, please ask any query if you have, please ask. Okay. Dear participants, you can unmute yourself and
Pawan sir, can I ask?
Yeah, why not? Please ask.
Thank you, sir. Sir, actually, while we are protecting our own URL, suppose our university URL is the www.IGNTUAC.in. And being a university, we wanted to be keep watch on our URL. So how we can make necessary arrangement at university side?
I don't get your question. What do you mean by protecting your URL?
I mean, suppose URL www.IGNTU.ac.in, इसके ऊपर अगर बहुत सारे अटैक हो रहे हैं या कुछ vulnerability आ रही है, how we can protect at our end, sir, on our website, web portal?
No, attacks on the web server is one thing, and attack on the URL itself, I can't understand. You can use many different approach. You can use many different approaches for protecting your web server. You can use but I don't understand your question. What do you mean by protecting the URL itself?
I mean, sir, suppose usually what happen, people are going to be get access on the entire our web portal. So how we can protect as a university to that untowards, rather than to be going after post-mortem. So in prevention point of view, do we have any major or any facilities, third party, we can give it our URL to them and they will detect from our side and they will give a list of vulnerabilities like that?
Yeah, there are many such professional services available. If you are hosting your site on any professional cloud service, then they provide you such services where they will provide you analytics related to that.
Thank you, sir. I think it is too much chaining tier security layer required, which is we having by default. Thank you, sir.
Thank you.
Any more query participants? Can similar approaches be deployed in design control system in a chemical industry? There is a one query in chat box, sir. From the Toishi Okogwe. Okay, I think it's from Japan or some from else. Can similar approaches be deployed in design control system in chemical industry? Vikas, sir, this is a question.
This is not visible to me. Where is this query?
The query in chat box, sir.
Let me access it. Where is the chat box?